Good afternoon, everybody. So, what is today's date? J 30th, 2081. This day will never come. Finished. There is one saying, time and tide wait for none. When I was a student, time was different. When you are a student, time is different, right? And in your time also you have seen many more changes, isn't it? And when your children will be student, at that time I think there won't be such type of technology. There will be much more advanced technology. No need to carry any books, any copies. There will be some device. You know, in America and Australia, I have just talked to the people and they say they don't have books. They have got Chromebook. You have seen my tablet, right? Or laptop, let's say. So each student will be provided with one Chromebook, but that Chromebook is mainly based on the course book. Like for class 4's all details will be over there, not other things. Class 5 only. Students, they carry it, they go to the class, teacher teaches, and they do all the works in that Chromebook only, finished. Up to class 5, no writing. Everything is done in Chromebook. And from class 6 they start writing. What I hear from nursery, A for apple, B for ball. Yes or no? Anyway, technology differs. SC 2081 batch, they are doing presentation nowadays, and we are nearly second last chapter for first term syllabus. What is the chapter? Force and motion, and we have discussed something about gravity, gravitational force. Gravity, what is gravity? It is the force of a heavenly body, either sun, Earth, Moon, Jupiter, Mercury, with which it pulls any object towards its center. Right? You know, when some stones are thrown up, or if anything is thrown upward, again, will it fall down or not? It's because of gravity. In gravity, it falls down. But another thing is gravitation. What is gravitation? Mutual force of attraction between two bodies. That is force of attraction only. But here in gravity, the body moves towards center of heavenly body. Here is gravitation. And next one is Newton's law of universal gravitation. Can you state Newton's law of universal gravitation? What is the statement of Newton's law of universal gravitation? Every body in this universe attracts another body with a force. Every body in this universe attracts another body with a force which is directly proportional to the product of their masses and inversely proportional to the square between their center. Directly proportional means if one increases, another also increases. Inversely proportional means if one increases, another decreases. And why is it called gravitational law? Newton gave that law, but why is it called gravitational law? Because this law is applicable throughout the universe for small bodies or for heavenly bodies, right? And while doing when he gave his law, then he just got one formula. What is the formula? Could you remember? F equals to G m1 m2 by d square. F equals to G m1 m2 by d square. So children, what is capital G? Gravitational constant. What is it? Gravitational constant. So how do you define gravitational constant? Tell me, how do you define gravitational constant? Gravitational constant is defined as the force of attraction between two unit masses. What is the definition? Force of attraction between two unit masses separated by unit distance. Very simple definition is there, right? What is that? The force of attraction between two unit masses separated by unit distance. That means just look at here. Suppose here is one body. Its mass is how much? 1 kg. Here is another body. What is the mass? Unit masses means mass is 1 kg. And what is the distance between their center? 1 meter. So this force is equal to gravitational constant. Gravitational constant. And do you know the value of gravitational constant? 6.67 times 10 to the power minus 11 Newton meter square per kg square, or Newton meter square kg minus 2. Kg minus 2. These things we have to remember. Okay. There is relationship between gravitational force and its factors and some numerical problems. So today's presenter is going to explain about it. Without wasting time, let's welcome today's presenter, Kumar Sharma. Give him a big round of applause. And his super guru. Who is the super guru? Raju Shah. Okay. Is there any question?
Namaskar everyone. I am going to present the force and motion chapter.
Will you make it bigger?
So, if the distance between two bodies is double, 2D by keeping their mass constant. So, according to this statement, the distance between the center of two bodies is double, keeping their mass of them constant, i.e. the distance between the center of the body is 2D. Then, after applying formula, we can say that the gravitational force of the body will be decreased by 4 times. As the distance increases by 2 times, its force decreases by 2 times. And now we have a numerical problem. Two bodies with a mass of 200 kg, each are kept 2 meters apart from the center of the surface of Earth. Calculate the force of attraction produced between them. So here we can get mass and the distance between them is 2 meters, and we know gravitational constant is 6.67 multiplied by 10 to the power minus 11 Newton meter square by kg meter square. And after applying formula, we can get answer. Thus the force of attraction between these bodies is 5.67 multiplied by 10 to the power minus 7 Newton. And this is again a numerical problem. What will be the force produced between the body of meter square is triple, keeping the distance between them constant. Actually, I think there is a mistake in typing. So let's take mass of an object is 200 kg. Another mass is 3 times the mass of J. So multiply by 3, we get 600 kg, and distance between them is 2 meters, and gravitational constant is given. And after applying formula, we get the answer. It is 2.001 multiplied by 10 to the power minus 6 Newton. And now gravity and weight of a body. So Nepal and America are located nearly opposite on the Earth's surface. While standing on the Earth's surface, the Earth pulls both them toward the center. This force is called the force of gravitation. It determines the weight of body pulled by the Earth. So gravity is a force of attraction between two objects, and weight is determined by gravity. In gravity is simply a special case of gravitation involving a heavy body. The gravitation between the earth and a body near on its surface is called the gravity of the earth. And we have consequences of gravity and gravitation and gravity. Gravitational force maintain the existence and position of the solar system and entire universe along with its component. It also helps in existence of the atmosphere surrounding the earth. Gravity is responsible for the revolution of planets, satellites and other members of the solar system. Rain, hails and snowfall are different products of force of gravity. Gravity plays a role in determining the future of universe and is responsible for the life cycle of stars and expansion of the universe. Gravity is the force behind the weight of a body. Thank you.
Newton meter per kg square. Force of attraction. By solving, we can get the force of attraction between two bodies, that is 5.67 into 10 to the power minus 7 Newton. What will be the force between the bodies of example 1 if mass of two is triple, keeping the distance between them constant. Mass of body is 200 kg and mass of another body is 3 times is 600. Distance between them is 2 meter. Gravitational constant is 6.67 into 10 to the power minus Newton meter kg square. Force of attraction, we can use same formula to calculate this. Gravity and weight. Weight is directly dependent upon gravity because the SI unit of weight is Newton because it is dependent upon gravity. Mass and weight are different. The weight differs from from Earth to other space because the gravity on Earth is 9.8 meter per square, but it is less in Moon. That's why weight is not constant everywhere. Gravitation is a simple and special case of gravitation involving a heavenly body. The gravity between Earth and body near or its surface is called gravitational of the Earth. Similarly, the force of attraction of Jupiter on body near or on its surface is called gravity of Jupiter. Consequences of gravitation and gravity. Gravitational force maintain the extent and position of solar system and the universe alone. The Earth revolves around the Sun because of gravitational force. It also helps in existence of atmosphere surrounding the Earth. Gravity is responsible for revolution of planets, satellites, and other members of solar system. Rain, hail, and snowfalls are the different products of force of gravity. Gravity plays a role in determining the future of universe, is responsible for the life cycle of stars and expansion of universe. Gravity is force behind the weight of the body. The Earth revolves around the Sun because of gravitational force. Due to gravitational force only, the Moon, our satellite, also revolves around the Earth. If there is not gravity, then Earth will not revolve around the Sun. Thank you. Have a nice day.
Okay, thank you. So I think if you do like this, it's better. Slide is here, and the slide is based on this thing. Where is it? Slide is based on. It was already got. How? So here is at first relation between gravitation and gravitation with its factors. What are the factors affecting gravitation? Number one, mass of the heavenly bodies. Another is distance between their center. So what is the relation? F equals to, relation is, what is the relation? F equals to G m1 m2 by d square. F equals to G m1 m2 by d square. That means force. Gravitation is directly proportional to product of their masses. Gravitation is inversely proportional to square of the distance between their center. It means when the mass of the body increases, gravitational force also increases. If mass decreases, gravitational force also decreases. If distance increases, gravitational force decreases. If distance decreases, gravitational force increases. I mean, just look at here. Here are two bodies. In between these, is there some gravitational force or not? But if we increase the mass this much, now what will happen? Gravitational force will increase or decrease? Mass is increased, no? Mass increase because relation is here, force also increases. Suppose here are two bodies. In between these two bodies, is there some gravitational force? Yes. Now, if the bodies are moved far away, gravitational force will increase or decrease? Increase or decrease? Decreases. Because distance increase, gravitational force decreases. So this is the relation. That's why it is given here. Relation between gravitation and gravitation with its factors. What is the first one? Read here. Relation between gravitation and product of mass of bodies. Suppose here are two bodies. What are the two bodies? M1 and M2. With mass M1 and M2, distance between them is, what is that? D. So what is the gravitation? F. What is the formula here? F equals to G m1 m2 by d square. This is obvious formula, right? Now what happened? Mass of body is increased. Now m1 becomes how much? Let's say 2m1. m2 becomes how much? 2m2. If mass increases, at that time new force will be G, and what are the new masses? 2m1, 2m2. Mass is increased, no? By distance is same. How much does it come? 2 2 ja 4G m1 m2 by d square. But G m1 m2 by d square is how much? F. So we can write simply here. What can we write here? It means if the mass of each body is doubled, look at here. If the mass of each body is doubled, the force increases how many times? 4 times. But if the mass of one body is only doubled, if mass of only one body is doubled, then what will happen? It will increase how many times? 2 times. So, if mass increases, keeping the distance constant, gravitational force also increases, right? That is the relation. Next one is, what is second portion here? I think sometimes it becomes a bit slow. Distance between them is doubled by keeping their mass constant. Now what is changing? Okay, here are two bodies. What is their mass? M1 and M2. So what is the value of gravitational force? G equals to, what is here G? Here G equals to, sorry, F equals to G m1 m2 by d square. This is first condition every time. But what happened? Distance is doubled. If distance doubled, then we can write F1. New force equals to G m1. Mass is kept constant. Mass is now here 2d whole square. Not 2d square, 2d whole square. Then what do you get here? G m1 m2 by 4d square. But G m1 m2 by d square is force or not?
Yes.
Then what we can write? 1 by 4 F. What to write? That means force increase or decrease? Decrease. How many times?
4 times. 4 times.
If distance increases, force decreases. If mass increases, force, that is called directly proportional and inversely proportional. Okay, here is some numerical problem. Can you see a numerical problem? What is given here? Please read.
Two bodies with a mass of
200 kg each are kept 2 meters apart from their center on the surface of the earth. Calculate the force of attraction. So 200 kg each means m1 equals to how much? m1 is how much? 200 kg. m2 is how much? 200 kg. What is the distance?
Distance
2 meter. What is the value of capital G? What are you writing, boy? 6.67 times 10 to the power minus 11 Newton meter square per kg square. What to calculate? F equals to what? We have, what do we have? What is the formula? F equals to G m1 m2 by d square. G is how much? Take out the calculator and do it. 6.67 times 10 to the power minus 11. M1 is 200 times 200 by 2 whole square. Okay, we can find out. Use the calculator. Use calculator and find the answer. 6.6. Well, see, no calculator here. Why did you keep that calculator there? You can, while coming, you must bring a book, bag, gadgets means calculator, not other gadget. Otherwise, 200 times 200. How much it came? 6.67.
10 to the power minus 7.
Sorry, 6.67 times 10 to the power minus 7 Newton. 6.67 times 10 to the power minus 7 Newton. You have to use calculator, right? So, such type of questions are similar one. Understood or not? Now the last portion is here. What is the last one? Students, what is the last one? Not weathering measure. Force. What are the consequences? How many consequences are there? I think here are given some. Consequences of gravity and gravitational force. Gravity is responsible for the revolution of planets, satellites and other members of solar system. They revolve around. Rain, hail and snowfall are the different products of the force of gravity. Because of force of gravity, they just fall. Gravity plays a role in determining the future of the universe and is responsible for the life cycle of stars and the expansion of universe. Because of gravity, we can say whether the universe will remain for long time, short time, and what about the age of star, it can be said. Gravity is the force behind the weight of our weight, means that much force of gravity is applied by the earth to pull towards the center. For example, for 1 kg, earth applies how much Newton force? 9.8 Newton force. 9.8 Newton force. Susmita, what is your mass? Suppose Susmita's mass is 50 kg. 30 kg is very less. Suppose her mass is how much?
50.
Then 50 multiplied by 9.8. What is the product? Calculate. How much? 490 Newton. So 490 Newton is the, what is this? Weight of Sushmita, that much gravity is applied to her by the earth to pull towards the center. Here is about acceleration due to gravity. This is earth. What is this? If any object falls down from here, if we drop down, automatically what is produced? One acceleration is produced. That acceleration is produced because of gravity. What is acceleration? Rate of change of velocity. Isn't it? Rate of change of velocity is called acceleration. So, if any object is dropped from a certain height, automatically what is developed here? Acceleration is produced. That acceleration is called acceleration due to gravity. What is it called? Acceleration due to gravity. So many are there. What is the next number? Gravity causes liquids to flow downward because it is pulled down. And gravitational force between particles of matter determine its state, solubility and other properties. If gravity is high, more, that is in solid, or bit less, it is in liquid, very less, it is gas. You have seen sugar dissolving in water, salt dissolving in water, but sand does not dissolve in water because the intermolecular force does not become weak by it. Okay, so this much is for today, and thank you once again to our presentator and Super Guru. Children, read once again thoroughly and again read with interest and note making. Okay, if you have completed your question answers, it's okay, otherwise you complete that question answer also. Understood or not? Start doing now. Thank you.
Sir.